You are welcome to class. Today we are going to be seeing how to quickly differentiate a function without having to go through the first principle approach. So let's go ahead now. So let's say we are given a function y is equal to x raised to the power of n. When we differentiate y with respect to x, dy dx will be equal to n x raised to power n minus 1. So we use the power n to multiply the variable there x, then we remove 1 from the power. As simple as that. So we are going to see some example where we are going to apply this. So we are asked to differentiate the following. So we are going to be seeing two questions right there. So we are going to differentiate y with respect to x. So starting with the first one, first thing we write our question. So y is equals to x raised to the power of 4. My n is now 4. So according to the formula above, say dy dx will be equals to, we use 4 to multiply x and we subtract 1 from 4. And when we simplify further, we get 4x raised to the power of 3. So even if we use the first principle approach, this is what you are going to get at the end of the day. So let's see the second one, 3x raised to the power of 5. So the 3 there is a constant, so we will rewrite it. So dy ds will be equals to 3. What we are actually going to be differentiating there is x raised to the power of 5. So 5 will multiply x and we subtract 1 from 5. So when we simplify further, 3 times 5 is 15. And when we subtract 1 from 5, we have 4. Okay, you can see that this formula is faster to differentiating a function. So we have some standard functions here with their derivative. You can look up for others in your textbook. Now if y is equal to 1 over x raised to the power of 2, we are asked to find dy dx. So let's see how to do that. The first thing, we write our question. But when we look at this properly, we can see that we can apply our negative index law from indices. So we can rewrite 1 over x squared to be x raised to the power minus 2. So dy ds will be equals to, we use our minus 2 to multiply x and we subtract 1 from minus 2. And when we simplify that, we have minus 2 x raised to the power minus 3. So again, we can apply the negative index law of indices and it simplifies to minus 2 over x raised to the power of 3. So now let's proceed. We are going to see differentiation of a sum. So if we have this type of question and we are asked to find dy ds, we are going to differentiate each of the function separately. That way, so if we differentiate 5x raised to the power 3, 3 will multiply 5 and we subtract 1 from 3, so we have 15x squared. The second one there, 2 will multiply x and we subtract 1 from 2, so we have 2x. The derivative of cos x is minus sine x, so that is the answer right there. Okay, so now let's move ahead. We are going to be seeing what is called function of a function, and the rule that we use in solving this is called chain rule. So if y is a function of u and u is a function of x, to solving those type of questions, we using the chain rule, and this is the chain rule formula right there. Dy dx equals to dy du times du dx. So let's see how to apply that now in solving this type of question. So we're asked to differentiate y equals to 2x plus 3 raised to the power of 4. So the first thing we are going to substitute. So let u be equals to 2x plus 3. Now we can rewrite y to be u raised to the power of 4. So first we'll do dy du. Remember the formula. So 4 will multiply u and we subtract 1 from 4. So we have 4 u raised to the power 3. Now we will differentiate u with respect to x. So if we differentiate 2x, we'll get 2. So having gotten those two derivatives, we'll just multiply them together by the chain rule. So we'll have 4u raised to the power of 3 times 2 2 times 4 is 8. So we have 8 u raised to the power 3. But remember, initially we don't know, we don't have a function called u, so we are going to replace u back with 2x plus 3. Okay, so with those examples, you'll be required to differentiate y with respect to x. So endeavor you solve everything correctly. Thank you.